Hi there, this is Ryan Malloy here at the Worldwide Center of Mathematics. In this video, we are going to discuss applied calculus versus calculus. So here we have a function f of x equals x cubed minus x to the fourth on the interval 0 to 1, which looks something like this. Now, if we were just doing a normal calculus problem, we might get a question like, what is 10 times the definite integral from 0 to 1 of f of x dx? And it wouldn't be particularly hard to compute this. We just find the antiderivative of this function, evaluate it at 1 and at 0, subtract the 2, multiply the result by 10. Not an unusual problem. But instead of this, suppose that we were given something else. Suppose that we were told that a team of engineers were designing a new form of speed bump. And the contour of the speed bump was modeled by this curve, x cubed minus x to the fourth, where x is in feet and y is in feet. And we're told that the engineers are building a speed bump that is 10 feet wide across the road. And we want to know what is the total volume of the concrete that will be used to create such a speed bump. And what we want to do is use calculus to figure out the answer. This is an example of applied calculus. Well, we start by finding what is the area underneath this curve. We can represent that with the integral from 0 to 1 of f of x. So we'll write x cubed minus x to the fourth dx. But then we want to multiply this quantity by the width of the speed bump, which, as we said before, is 10 feet. So we'll just put that out in front. But we see that this is exactly what we had before. It's just 10 times the integral from 0 to 1 of f of x dx. So with applied calculus problems, which typically take the form of word problems, there's usually only one extra step. You just have to figure out exactly what is being asked in terms of calculus. Then once you can figure that out, straightforward process to figure out the answer. My name is Ryan Malloy, and we've just discussed applied calculus versus calculus.